Hello, this is the chapter 2, and in this chapter, we will learn the electromagnetic energy and satellite image characteristics. There are two aspects, electromagnetic energy, and second is satellite images characteristics. So, if you recall this image in chapter 1, we have already discussed there are 7 elements of the remote sensing. And if I group these 7 elements, so the group there are two, group 1 and group 2. The electromagnetic energy is related to A, B, C. So in the electromagnetic energy, we will focus on this A, B, C part here. That what is electromagnetic energy? Okay, electromagnetic energy from the sun, how it interacts with the atmosphere, and how it interacts with the surface or the target. So this is the first group, and in this group we will learn electromagnetic radiation and electromagnetic spectrum. And in the second group is satellite images characteristics. It is the group of D, and we can say D, E, and up to some extent F also we can say, but largely D and E. So this is the theoretical base of remote sensing, and the significance of this chapter is that if this chapter is clear to you, then you can sit with your laptop and computer and you can produce the reports and the results with the help of satellite data. And let me make another thing is that as time is passing, the satellite, if we see a little the history, then the satellite programs uh, for remote sensing were started, we can call 1972 1972 up to now is a continuous process. So the images quality in 1972 and now there is a lot of difference. As we know that in communication also, earlier it was only 1G, now it's 5G. So the thing is that from 1972 up to now, there are many programs which belongs to the uh, satellite programs, and these satellite programs are dedicated to the remote sensing analysis. There are many programs, and these programs are from maybe from United States of America, or maybe European Union, or maybe another parts of the world. So as I told you, there are many programs since 1972. You can imagine there may be more than 10, 15, or maybe more than that, many programs. So earlier, what uh, was the problem that we were going to each program, I mean, an individual program, and we were acquiring the images of that program, and we were taking these images to our computer and we were analyzing. So it was a very tedious and problematic part here, that you are going and you are taking individual images, you are taking their parameters, and thereafter you are doing some analysis. But fortunately, here what happens, there is an entry of one organization, that is we know that this is Google. Google entered into this system, and what Google did, Google acquired all these images right from 1972 up to now, and continuously they are acquiring. And Google made one, uh, we can, in simple language, we can say, I store all these images are now in the store of the Google here. And this is known as Google Earth Engine. Google Earth Engine. Do not confuse with Google Earth. Okay, Google Earth is simple platform, but here I'm talking about the Google Earth Engine. Engine is added. So now this Google Earth Engine has acquired all the images. Now no need to go to the individual programs, but you just have to go to the Google Earth Engine and you have to choose the data they have, and they have made it very easy to explore the data, to analyze the data, to interpret the data, and to make the reports, to develop the reports, and even you can develop the applications also very easily. And these applications will be very helpful to understand the phenomena, whether natural or cultural, on the surface of the earth. So for all this process, you need to know, first of all, your basics should be clear, that what is electromagnetic energy and what are the satellite image characteristics. Let me relate it with a very simple example, that if we know the characteristics of the mobile, then we can go to the market and we can buy a good one. Like, what are the characteristics of the mobile? The characteristics of mobile or laptops are that what is, the maybe the what is the RAM, and okay, what is the RAM, what is the hard disk, what is the processor, and what is the generation. All these are the characteristics. Similarly, if I come to the remote sensing, so satellite images are having some characteristics. Okay, like how many bands are there, how many, the what is the spatial resolution of that image, and what is the time coverage. All these are the characteristics, and a very simple characteristics which will help you. Let me show you a little, then thereafter we will move to the chapter 2 to learn the electromagnetic energy and satellite image characteristics. So here, this is the Google Earth Engine catalog. You can see this link here. If you will, I will give you the link the in the description box, and you can click at this link, and you will see that there are different data types here. You can view all the data sets here. There are countless data. I mean, not countless, but we can say uh, varieties of data here. Okay, and this data, if you want to browse by tags, you can click here. There are tags. Tags means, I mean, there are some headings here. If you want to study the cropland, if you want to study the crops, if you want to study the coastal areas, classification, climate, okay, districts, at, then you can click and you can see the data characteristics, and you can browse also the data. So uh, as we can see here, this is all data, and if we are interested for Landsat data only, you can see the Landsat data here. These are the this collection is of Landsat data, and the latest one is Landsat 9. If you want to browse it, you click it here, and thereafter you can go for the surface reflectance, then tier 2 data. And as I was talking, that the characteristics of the images, that the data set availability from which date to which date, and uh, if you want to study the description, you can study description in detail here. This data set is like this, and these are the bands. These are the bands. Band number one, two, three, four, five, six, like that. Okay. So this is the Landsat. You see the top of the atmosphere data, and here these are the bands name, band 1, 2, what is the pixel size, what is the wavelength, and for what it is important. So all these are the characteristics of an image. Okay, an image has different bands. Okay, and when I say the wavelength, this is what? This is energy. This is energy. Okay, this is the part of the energy. This is the part of the energy. In whole, this is all the solar energy, solar radiation. And solar radiation is divided into different bands. Okay, the bands. So that's why the this chapter is very important. Chapter 2, it will give you a theoretical base to understand the satellite images. And these are the different bands, but if there is only single band, that is also very important, and you can study like as I was discussing that before, that a single band, if anything related to socio-economic development, if the data is the night light data here, and here this image shows okay, what image I'm using here. uh, Actually, this what image I'm using here, let me explain you this one. This is the nighttime light data. So okay, nighttime light data, maybe, yeah, this is okay, this is nighttime light data. So you can see that who developed this data, what are the bands, and what are the minimum maximum values. So it's very easy, and here you can go for multi-temporal study. I mean the temporal study. Here I have taken three different years like 1993, 2003, and 2013. So when I started Google Earth Engine, then I was looking at this code. So do not worry about this code, because these codes are, if you will see here, these are ready-made codes available for you. If you will click at this see examples, you will find the code, and just if you will click, you will go to the code area. Okay, you can see okay, see the example here, and thereafter it will come, the code will come like this, and just you need to change the dates. So for an instance, the socio-economic development, the satellite is detecting the night light radiance values. And here in this data, for an example, say this is the Abuja here, and if I say the Abuja, and there are 3 years, as I told you, 13, 2003, and 1993. And this is the combination RGB, red, green, blue. So red belongs to 2013, green belongs to 2000, 2003, and blue belongs to 1993. So now you can uh, understand that if all these 3 years values are high, if R is high, G is high, B is high, red is high, green is high, blue is high, then it will be white area. So this white area is the indication that this is the area which is a stable light since 1993. Okay, but the green area shows, if this is the green area, means like this here, that in 2003 light was there, but it is not as much in 2013 and 1993. Similarly, look at this, 2030 is red. So red area shows that, okay, before 2030 here night light was less, but after 2013 the night light uh, was developed. So which are the areas where night light was developed? You can see here, this is the area which like this is, I think this is the airport road, so immigration quarters. This is the area, uh, Gladima, Lokube, okay, and this is the area where the development took place after 2010 or 2013. Similarly, this is the Abuja here, but if you can see, okay, in the south, you are looking at some information that the green area is 2003 more light, but after that, here some development stopped. But okay, this is the seaside, and the bright light shows that all throughout these 3 years, the light was more. So such type of analysis, which is helpful for socio-economic development, is possible with the help of remote sensing. Here I was just talking that how remote sensing is so significant for the geospatial analysis or the socio-economic development. So I'm coming to the first part of the chapter 2, that is the electromagnetic radiation. This electromagnetic radiation, if you see here, I'm talking about this A part here, and this electromagnetic radiation is, we can call it the energy also, electromagnetic energy. So yeah, this energy is in the form of electromagnetic radiation here. There are two characteristics, simple, is the wavelength and frequency. I mean, this energy we can classify, or we can understand with the help of wavelength and frequency. In remote sensing, the this is not the important, is what the wavelength. Okay, the wavelength bands were assigned the based on the wavelength from this length to this length here. So this wavelength is denoted by lambda. Okay, wavelength, what is, I mean, what is the unit? How it is measured? It is measured in metric unit. Okay, this is meters here. So meters you can divide nanometer, micrometer, or centimeter. Generally, what happens? They give the information in micrometers generally, and they can give in nanometers also. Okay, there are 6 band. The band number 1 is from this micrometer to this micrometer. Okay, and the frequency is the number of cycles of a wave passing through a fixed point. So uh, you can think of it, but again, I'm saying focus on the wavelength here. Okay, so as you can see here, this is a light which is passing through a prism, and this is a very popular practical in physics. So if you are passing a light, then you can see these colors here, means the energy has been I mean, this energy is disintegrated here, and you can see this disintegration in the form of the waves here. You can see, as I told you, you can see, I mean the eye, the human eye. So human eye is also a kind of sensor or detector, and it is not unlimited. Our eye cannot see unlimited energy. Our limit is This only this red, sorry, the visible part only. Okay, I will discuss it in detail, I mean in the next slide. So if you see here, the, as I was saying, electromagnetic radiation, and this radiation, if we say that electromagnetic spectrum, so the all spectrum is a, first of all, it's a continuous range of electromagnetic radiation. So the least wavelength, the smallest wavelength is the gamma rays, X-rays, then it comes to ultraviolet, then visible, then infrared, microwave, television, AM radio, and long wave radios. The point is that which part of this spectrum is important from the viewpoint of remote sensing? Then its answer is from visible part to we can say to microwave also. But here in the in the passive remote sensing, we use only this energy here, visible and infrared only. Okay, so visible is here, in visible part, we can say in visible part, this is what, sorry, this is not visible, this is visible. Here in the visible part, there is a green energy, there is a, sorry, there is a blue energy, there is a green energy, and there is a red energy here. Blue, green, and red. What is this blue, green, red? We can see here. So in remote sensing, in what energy we have to focus is visible and infrared energy. This is the part. Okay, and this energy is, I mean, is a continuous. Remember, it is not discrete. The visible part does not mean that right from uh, 0.6 sorry 0.4 micrometer to 0.7 micrometer only. Here and there little bit there is some characteristics of visible light. So uh, here remote sensing involves measurement of energy in many parts of electromagnetic spectrum. So this is as visible light important, okay, reflected and emitted infrared is important, microwave is important, but here we are talking the 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 the, the passive remote sensing here, or passive remote sensing. Microwave is related to active remote sensing. Okay, okay. See the next here. The satellite sensors have been designed to measure the responses within a particular spectral bands to enable the discrimination of the major Earth's surface. Okay, the sensors are here. These are the sensors. And when we say the energy, and the energy is now divided into bands: blue band, green band, red band. So all these bands, when interact with any material on the surface of the Earth, they respond differently, and their response is how much is energy being reflected from those material. And now look at this down here, the green area. Why it looks green? Because of it's simple, it's an energy interaction behavior with the material, with the leaves, with the trees leaves. Okay, the tree's leaves characteristics is that when energy comes to and interact with the green leaves, the green part of the electromagnetic radiation is reflecting more. That is why it looks green. Okay, so let me say one more thing. As I was saying that our detectors means our eyes has no unlimited power to detect the whole energy. We detect only the visible part, okay, visible part of the energy. But why we are studying the infrared then? Because infrared is a hidden energy which our eyes cannot detect, but infrared, when it reaches the surface of the earth, this energy is very useful for remote sensing analysis. And the this is we can say the significance of the scientists who develop such type of sensors which can detect the infrared energy, which can detect the infrared energy. So remote sensing is making you very powerful, I mean a giant, so you can see a larger area of the earth, and you can study the more energy. Okay, like you can study the infrared energy. So on the one side, you are able, with the help of remote sensing, you are able to study very large area. Even you can, whatever the, now this is your eye. This is your eye. This is, all these sensors belongs to you. Whatever they are sensing, as much, even at the whole continent, you see the image and you study, and you can give the information. Okay, this is the climate, this is the temperature, this is the rainfall, this is the soil moisture, this is, so this is the infrared energy which I want to focus here. The infrared energy is very very useful, especially to study the vegetation and water content or the soil moisture, etc. So if you see the visible spectrum here, the first one is here given, that is the visible spectrum. The visible spectrum here. So visible spectrum, it starts from 0.7, sorry, it starts from 0.4 here. Starting from here, okay, 0.4 micrometer and end 0.7 micrometer. Okay, so 0.6 to 7. Okay, so in general, 0.4 to 0.5 is the blue part of the energy. This is what? Blue part of the energy. 0.5 to 0, sorry, 0.4 to 0.5. Remember, I think it's not given here, but you can see 0.4 to what? 0.5. This band is the blue energy. Okay, remember this thing, and it's very important. 0.4 to 0.5 micrometer is what? The blue light. Now come to the green here. Come to the green. Green is 0.5, 0.5 to 0.6 is a green energy here. This is what? Green energy. And the next is 0.6, 0.6 to 0.7 is the red energy. So remember, it's continuous, easy to remember. 0.4 to 0.7 is the visible part, here. This is visible part, okay? And if you divide the visible part 0.4 to 0.5, because when you will see the characteristics of the band, okay, then you have to keep in your mind, okay, this is 0.4 to 0.5 is blue energy, is this is 0.5 to 0.6 is green energy, and 0.6 to 0.7 is the red energy here. This is red, this is green, and this is here blue energy, blue energy, blue energy, okay? And this is all, these are the colors, okay, all these are the colors. And when there is some, I mean, energy like 50% is red and 50% is green, then it will be yellow. If anything is reflecting 50% red and 50% green, then the color will be yellow. If anything is reflecting 50% blue and 50% green, then this color will be there. This color here, as you can see here, this color, in this color, okay? And now there are different types of mixing, maybe 20% red, 80% green, then different colors we see on the surface of the earth. Within in your environment, you can see whatever you are looking at, there are different colors, and all these colors are because of the interaction of energy with the target, okay? Just for a tree, a plant, the leaves, first they appear green. So they are appearing green because of a pigment that is there is a, you know, this is the chemistry of the leaves inside. It makes responding like this. So this is what it appears green. But the chemistry, when it loses, water content loses, or the photosynthesis activity decreases, then that I think is chlorophyll. When it reduces, then color change to the first yellow, thereafter red. The leaf first is green, then it becomes yellow, then it becomes, if it is dyed, it becomes reddish here. So okay, so this is what visible spectrum, which is very important, and blue, green, red. Remember these values here. So this is you know within visible part. Within what? Visible part here. This man, a red color man, is a heavy man, and this man is moving very fast. And it, in this example, it is consider it is a red energy. So red energy has higher wavelength. That is why it is moving so fast. Okay, while this green uh, man is just jumping, it does not have as much wavelength as red. Another, this blue one is just, you know, trying to catch all these three because the wavelength, blue light wavelength is less here. So it was just to memorize. I mean, you can have an idea that okay, red is wavelength is very high. So let's move next. The the infrared energy, which starts from 0.7 micrometer and it ends 3 micrometer. Okay, this is what this is. Well, let me here 0.7. This is one part of the reflect infrared. Okay, look at this. This is 0.7 to 100 micrometer. 100 micrometer, and this part is only the reflected part. Here you can see this one 0.100 micrometer. Here this is ultraviolet visible part, and this is the infrared part. Here this is the infrared part. So the infrared part is here. Yeah, this is infrared. Okay, this is infrared. So infrared starts from 0.7 to 100 micrometer. Remember, let me write it here. Infrared starts from 0.7 to 100 micrometer. But this whole group you can divide into two subgroups. One is 0.7 micrometer to 3 micrometer. So this one is the behavior is like the reflected one. Okay, it is called a reflected infrared. This is called reflected infrared. Infrared. And okay, another is from 3 to 100 micrometer. 100 micrometer. It is known as thermal infrared. Okay. So this thermal infrared energy you are using to measure especially the temperature on the surface of the earth. Temperature helps you to detect or to discriminate uh, many more things, like you can study the surface temperature also, top of the atmosphere, what is the temperature, means detected by the sensor. And this is for thermal infrared is for temperature, especially to measure the temperature. But the reflected energy is very useful to study the vegetation, to study the water content, and water may be the sea water, maybe the fresh water, it may be within the small lake, larger lakes. You can study the water content in the soil also, like soil moisture. You can study the vegetation very well in with the help of reflected energy, reflected infrared energy. While thermal infrared is used to study the temperature on the surface of the earth. So remember these bands here. And now so far I have already talked the A, A part. A part was what are the characteristics of the energy in the form of radiation studied in the form of a spectrum. Then subspectrum means the bands, in the form of bands. Now I'm jumping to C part here. That is the energy interaction with the earth surface. I'm just uh, the B point here. B point is energy interaction with from sun to the earth. Here this is the atmosphere here. So this is also important to know that how this radiation is interacting with the atmosphere. Uh, and it's a long topic, but just for your understanding that there are three things there is the absorption here, there is uh, scattering, and there is transmission. There is transmission. So the atmosphere is absorbing also some of the energy, like ultraviolet is being absorbed by the ozone layer. So this is what absorption. So it becomes unimportant for us for remote sensing because it has been already absorbed in the atmosphere. So it may be important if you are studying some atmospheric phenomena, but the phenomena related to Earth's surface, this energy is already absorbed, is not reached at the surface. The second is the some energy is scattered. Energy means when the particles are coming, the photons are coming to the earth, then there are some particles, gases, which interact with the radiation, and this radiation is getting scattered here and there. So this energy is also waste in the atmosphere, so it's unimportant for remote sensing. The energy which is transmitted to the surface of the earth is important for us, for the remote sensing analysis. So generally what happened, the why I said that gamma ultraviolet, because these energy is not coming to the earth surface being either absorbed or scattered in the atmosphere only, and this visible part is coming. So this is important. So that was the interaction with the atmospheric part. Here there is no slide for that, but the significance or very significant is the earth interaction, sorry, energy interaction with the earth surface. How energy is interacting with the surface of the earth. So that energy is also, here we can say that it is either absorbed or transmitted or reflected. Now think that which one is important from the viewpoint of remote sensing. Is it absorption, absorbed energy, or transmitted energy, or reflected energy? Guess what should be the answer? The answer is reflected energy. Why reflected energy? Because if this is the earth here, if this is the earth here, and here is the satellite, the absorbed energy has been lost to the earth because it is already absorbed. Similarly, the transmitted energy also lost, but the energy which interacted with the surface of the earth and thereafter reflected back. So this reflected energy is being detected by the sensor or by the satellite sensor. So reflected energy is important. Okay, and this reflected energy helps us to differentiate, to detect, to discriminate, to analyze the satellite imageries. Okay, because absorption is also kind of information. How this is information? Because if sun energy is coming and water has a characteristics that it absorbs most of the energy is absorbed by the water. So reflected energy will be very less in those areas where water is there. So such type of areas will appear you darker, dark in color, but in water, what happened, a little bit blue light and green light is reflecting little higher than red. That's why the water appears blue to us. Okay, now let's see here three things: absorption, transmission, and reflection. What is important, which is being detected by the satellite, is the reflection. Okay, here this is an example that, okay, this is the energy coming here. There is blue light here, this is blue light here. Okay, this is blue light here, this is green light here. This is red light here, red light here, and this is infrared light. What color should I take for infrared? Yeah, we can take this one also, but this is infrared. So what is more reflection is? More reflection is green and infrared. If you will compare the energy reflection, then infrared is so high. It from healthy vegetation, 90% energy coming, infrared energy coming. I mean the tree, the leaves. In another word, no need of infrared. Go back. They hate infrared. Who hate? The healthy trees. Sorry, healthy leaves of the tree. I mean, if the leaves will be healthy, tree will be healthy. So that is why I told you that infrared energy is very helpful to study the vegetation. Very, very helpful. Okay. And now I'm coming to the water here. In water, the reflection here. That is the reflectance. That is the reflectance. How much energy coming and reflecting. This is the sun here. Okay, this is the sun here, and here this is the earth. This is the earth, and if blue light is coming down, okay, blue light is coming down, then the light is measured into, I mean the radiation is in watt per square meter per strain. Okay, this is the unit of radiation here. But the another important is reflectance. So reflectance is in percentage. Like if 200 watt energy coming and 100 watt is absorbed and 100 watt is reflected, then how you will calculate the reflectance? If 200 coming, 100 absorbed and transmitted, and 100 is here, 100 is here, then it is only 50% reflected. It is only 50% energy is reflected here. Okay. This is, I mean, how much energy coming and how much is reflecting. That radiance coming and moving out is the ratio. That is the reflection in percentage. It's very simple now. It becomes very simple. So if you will see the water, if you will see the water, this is the graph of water here. Okay, graph of water. This is the reflectance from water, from water. This blue energy here, sorry, this is the blue energy, this is the green energy. You remember the bands I told you before, and this is the red energy, and this is the infrared energy. This is infrared energy. And now you see the graph of water here. The water is maybe only 4 5% here, because this is 0, this is 20, this is 30. So close to 0. I mean the absorption in here, the reflectance of blue is here, then green is here, then red is here. But in the infrared part, the water has absorbed the infrared energy. Water likes infrared energy, and it is absorbed by the water. Infrared. On the other hand, the vegetation does not like the infrared energy. So maximum infrared energy will be reflected here, will be reflected out. So if you have the image, the infrared image, the higher values will show Vegetation or water? Vegetation or water? If this is the infrared energy, so infrared band, so the higher values will be the vegetation or water. The correct answer is it will be the vegetation. And the lower values, darker areas will show what? The water. Because the reflectance is high in vegetation and reflectance is very low, is zero. Okay, the water, so very low reflectance will be there and highly absorbed, it will show you dark. Okay, so just let me give an example here just to demonstrate to you. So just to explain the energy interaction with the target or the surface of the earth or the material which is on the earth surface, let me demonstrate it with some Landsat data here. And what I will do is I will take Landsat, all this time is given that Landsat 9 belongs to 21 to present and 8 belongs to 13 to present, 7 1999 to 2021, and this is 84. So temporal study, yeah, I mean the changes you can study with the help of such type of data. Here, let me take this Landsat 5 here, Landsat 5, and when you will see the Landsat 5 data, and you look at this Landsat 5, let's have a top of the atmosphere. So there are how many bands are there? 7 bands are there. So infrared is 0.62, sorry, 0.762, 0.90 micrometer. So earlier the band which I was explaining, that is the minimum and maximum limit. Here in between minimum and maximum there may be any, it depends on the program. Okay, so in this Landsat 5 program, the Landsat the infrared band is the band number 4. But for your understanding, if we say that Landsat 8, in the Landsat 8, this is not band 4, this is band 5, that is near infrared. Why it happens? Because they added one more band in the visible part. They added one more band. So as time is passing, the bands are increasing. So to give more and more information, so band number 4 is not always the near infrared. In band Landsat 8, the band 5 is infrared. Here I'm talking Landsat 5, that is Landsat 5. Band 4 is the red one. Okay, so I'm using this image here, and if you will see, you can look at the image I have taken here. This is the, I think, yeah, this is the Landsat 5 05 is Landsat 5. Okay, sorry, here you can see Landsat 5. Okay, the image is 2000 here, 2000 here. So I have taken a part of the earth where you will see the water, you will see the vegetation, and my objective is to explain you that how band number 4 behave with vegetation and water. So there are, okay, this is the true color image composed of 3 bands. These are the visible bands here. These are the visible bands. That is 3 red, 2 green, and 1 is blue. But I want to see that only one band, that is band number 4. Band number 4 is here, is infrared, near infrared band. Okay, I will do it, apply. You see how much difference is there, how much difference is there, and you can see this difference here. This is vegetation area. So in vegetation area, Band number 4 is high values, very high values. This is band number 4. The value is 15,000. These are the DN values. On the other hand, if you will see, band number 4 is only 8,000. Okay, but if I will take this here, it is even 9,000. So in the water area, infrared energy is disappearing. Why? The more infrared energy is getting absorbed by the water. On the other hand, in the vegetation side, the near infrared energy is getting higher. Higher. So this is all, all energy. Okay, let me show you the RGB, means the combination of three bands. So here this is red, green, blue. Our red is here band number 3 in Landsat 5. This is band number 2 and this is band number 1. Apply it, then this will be a true color image. You see, when you will mix red, green and blue, the image which will be developed, it will be true color image. So now if you will explore this system, you can analyze yourself that which band, how is the behavior with different material. Okay, let me show you, like if I'm using here Sentinel. Okay, okay, let's begin. So once you are, let me close all of this here. Yeah, this is the beginning. If you want to explore some data like Sentinel, here maybe a Sentinel an example, then you see here in the Sentinel data there are different types of instrument they have. Instrument means the sensor and detectors. So this is multi-spectral, that starts from 2015. Now tell me, Landsat start from 1972. Sentinel started from 2015, which is important from the viewpoint of time series analysis. Of course, Landsat, but Sentinel has its own advantage. When you will see the Sentinel data, its spatial resolution is better than Landsat data. So this is Sentinel 2 here, and let me see the any here. Okay, so they have shown here. Okay, maybe they have the examples here. Okay, explore with Earth Engine. When you will open this code, when you will start, you may not be able to work with code editor. Why? Because you have to register, you have to make registration. Okay, after registration they take generally 1 or 2 days, and they will give you the permission to use this code dot earth engine. So let me explain it. Okay, when I will click this, you see the quality of the image. With the help of this image you can see, uh, many more things. Because why? What is the reason? Because the spatial resolution is 10 meter. What does it mean? That when you will zoom in more, when you will zoom in more, this is the pixel here. 1 pixel is here. When you will measure the distance, is 10 meter. Okay, so the pixel size is 10 meter by 10 meter. If it is smaller, quality will be good. So this is one of the characteristics, that is the spatial resolution. We'll talk in the coming part in this chapter. And but what I wanted to show you is here, you check this inspector and click here, you will find the reflectance of each band here. Band 1 reflectance is only 8%. This is water here. Okay, so reflectance in all bands is given here in percentage. Okay, so in water area, so the details of the bands are here. This is band number 5. Band number 5. Now you check this one. This is 0.7 to 0.7. This is also red, but this is infrared. Band number 8 is infrared here. This is in nanometer, okay? So 0.82, this is near infrared, and that is band number 8. And now you see band number 8 here. Band number 8. See the example of water here. This is water. And here band number 8, yeah, the reflectance is only 3% because water is absorbing more infrared energy. But if you will see the vegetation, some vegetation area, yeah, so vegetation area, then this infrared energy is 24% here, 24%. So as much difference is there in the bands when it comes to the interaction with different material. And if you are interested, if you want to know that, okay, this is what, this is bright light area, something which is giving high value, what is the interaction of energy with this material? So you can check by yourself here. This you will click by inspector. The interaction is that all the bands, it's a high level of reflectance. And when red and green and blue is reflecting high in equal, almost around equal proportion, then the color will be the bright, or the color will be the white. Okay. So this is this graph you can see here in form of the values also. Okay, this is high reflectance. But here with water, reflectance changes. Okay, you can see in pictorial form also. So this was about the sun radiation, solar, I mean, uh, spectrum and bands. Now we'll talk about the image characteristics, and which I have, it will be easier to understand to you the image characteristics because I have already talked about the pixel size. This is the spatial resolution, the wavelengths, it is a spectral resolution, and these are the two resolution only which are very important from the viewpoint of remote sensing. Another is also there, that is radiometric resolution. Radiometric resolution indicate that in between lowest and highest value, how many discriminations are there, how many values are there. So let's see. And now here we'll talk about the satellites and images characteristics here. There are two. One is the characteristics of the satellite, and another is the characteristics of the images. So the satellite broadly we can classify into two categories. I mean the passive sensor, it is called passive remote sensing, active sensor, active remote sensing. In passive sensors, passive remote sensing, it's a process which I'm discussing. There is a sun, there is a energy, there is a reflection, and there is a detection. So it is what passive sensor. But generally, what happened? The problem is in between, in between the sensor and the Earth, there are clouds. So because of this hindrance, you cannot go for remote sensing. Then what people did is they have developed the active sensors. Active sensors are not dependent on the energy. I mean, during night also, you cannot go for passive remote sensing. So what they did is they developed the active sensors, and these active sensors give the energy, send the energy, especially microwave energy, and this microwave energy comes to the earth and again reflect back to the sensor, and because of this energy they do remote sensing. They study the surface of the earth. So this is what, this is active remote sensing, this is passive remote sensing. Okay, and the next are the platforms. There are different platforms which can be used to to study the surface of the earth. All these platforms are having some cameras or these sensors, the scanners, detectors, which give you, which detect and give you the information. This is helicopter, this is satellite, this is space shuttle. And so the important one from the viewpoint of remote sensing is the satellite optical sensors. Satellite optical sensors here. Okay, because these satellites are giving the information of even maybe 10 centimeter spatial resolutions, 10 centimeters of spatial resolution. Sorry, spatial resolution. What is the spatial resolution? We'll talk ahead. Then, what are the satellite characteristics? Okay, the satellite characteristics based on the movement, the satellites can be divided into two categories: geostationary and sun-synchronous. And the purpose is different. Objectives are different. If your objective is that you have to watch only a part of the Earth, then you need geostationary orbit or geostationary satellite. And these satellites are the communication, used for weather reporting, uh, used for sending the signals. Okay, so these are known as geostationary. Geo plus stationary. Stationed, I mean synchronizing with Earth. So their movement is also like this, and they are very far from the Earth, so they should cover the larger area. That is why they are very far from the Earth. And their movement is matching with the rotation of the Earth. As the speed of the rotation of the Earth is similar speed, they move with the similar speed, and this is the logic behind that they becomes stationary for one area. Okay, the movement is like this. The Earth is moving like this, west to east direction. So these satellites are also moving west to east direction. Okay, so these are the geostationary. This is geostationary orbit. On the other hand, sun synchronous is this. These are the satellites which revolve around the Earth, pole to pole, pole to pole. Okay, pole to pole. So they are synchronizing with the sun. They always remain with the sunlight, because if, for example, this is the first round of the satellite, it will go back and then come again, and the Earth has rotated from west to east, then another rotation will be this side here. Okay, then third rotation will cover this area, and the fourth rotation will cover this area. So Earth is rotating west to east, and these satellites, the orbit looks as shifting from east to west. So they remains always with sun, and which is very important for the remote sensing which I was talking about. That is the passive remote sensing. Swath is the width of sensing. Okay. Generally, if satellites altitude is high, altitude is high, the swath will be more. And if swath is more, then the quality of image will be down from the spatial resolution point of view. Pixels will be larger. But if satellite altitude is less, close to Earth, then this swath will be less, okay, and the image quality from the viewpoint of spatial resolution will be higher. So each and I mean every program gives that what is the swath of this. So this is also the characteristics of the program. And now I'm coming to the point. This is the point. What are the satellite image data characteristics? Because if you are able to understand the image data characteristics means you are remote sensing analyst. Okay, once you know that okay, this is the image and these are the characteristics. Okay, as you have I have shown you before that spectral band means how many bands are covering the bands. I mean like for an example here, this is one band OLI. This is the name of the sensor which is Landsat data. Okay, Landsat. So Landsat is giving you information of this band blue, giving you information of green, giving you information of this red here. This is red, this is green, this is blue. Blue are two, okay, and this is band number 5, then 7, and maybe this another names are also there here. I mean, okay, this is one, this is another. So there are around maybe uh, 9 or 10 bands something. So here how many bands? 10 bands. Here 1, 2. This is what? OLCI. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Many bands. Okay. So if this program is giving suppose 25 bands, then which spatial resolution is better, here or here? The answer is here, 25. Why? Because it is giving you more bands. If there are more bands, spectral resolution is high, more. If there are less bands, spectral resolution is down. Because you are blind here. I mean this part of the electromagnetic spectrum is being covered by this program OLCI, but it is not being covered by another satellite. So that's why this program becomes important to study if you need the information of this particular wavelength to detect a particular type of maybe mineral, maybe a rock, or like that. So this is the significance of spectral resolution or spectral bands, which is of course equally important as or even more than important than spatial resolution. So this is spectral. Spectral means you are talking about the electromagnetic radiation. You are talking about the wavelengths. Then it comes the spatial resolution. Spatial resolution is that the pixel which I showed you in the image in the square shape, what is the size of that pixel? And what is pixel? Pixel is the smallest unit or smallest element of any picture or image. Image is composed of the pixels. So if pixel size is less, there are two examples here. One is 15 meter and another is 30 meter resolution. So which, if this is A and this is B, my question is out of A and B, which has better resolution? Is it 15 or 13? So answer is A. Why? Because the size of the pixel is less. Here the size of the pixel is more. Here anything smaller than 30 meter will not be visible to you, may not be visible to you if it is not making a pattern here. But here it will be visible to you. It may have maybe 4 pixels here which are covering the table. So these pixels are having the information. These pixels are having some DN values. So these values will help you to understand that part of the earth. So this is what is spatial resolution. Okay. So temporal resolution is if this is the earth here and satellite is moving, this is a name of the area A. Okay. The first round the satellite is January 1st. Then the satellite will move here. Then satellite will move here. Then it will rotate here. And the first visit was January 1st. This is January 1st. And the second is January 15. So 1 or 15, there is a difference of how many days? This is 15 days. Okay, these are the 15 days. So the temporal resolution is 15. Revisit. Here I'm talking about the revisit. Okay, when your satellite will revisit. So this is revisiting time is the temporal resolution. If this is 15 days, condition A. Condition B, if revisit time is 30 days, then which resolution is better, A or B? The correct answer is A, because within a month you will see 2 times of your area. Here you can watch only one time. You can analyze only one time in a month. Here 2 times. So the temporal resolution here is better than B. Okay. The next is the radiometric resolution. Radiometric resolution is, suppose there is a band here and one band, this is the any area here. And in this area there will be values, low values and high values. Okay, so radiometric resolution is something which is related to the processing level down by the scientist, and if the low value is 0, here 255, highest is 255. This is condition A. The condition B is the lowest value is 0, the highest is 6, 5, maybe 6554, something like that. So this is highest, this is lowest, 0. So which radiometric resolution is better, A or B? Of course, this is B, because here you can see many more differences on the surface of the earth. Many differences will be visible to you. Here it will not be as much visible. Not only visible, from the viewpoint of analysis also, this radiometric resolution is far better than A. So this is the change. Landsat before 4 was having, this is maybe 8-bit data. Now the second came to the second bit data. So this is measured in the bit. So this was the radiometric resolution. Remember, sorry, there are 4 characteristics I told you of images. Out of these 4, of course, 2 are very important. One is spectral resolution and second is spatial resolution. So at the end of this chapter, what I will advise you, you take each and every topic to the Google and you can type it on the especially the YouTube, then you can read more. You can watch the videos related to the image qualities, I mean images characteristics related to satellite characteristics and related to the remote sensing analysis, that you can enhance your knowledge. So this is all about chapter 2, and we will meet in the chapter 3 next time. Thank you so much.